In this example, what we want to do is start with real data and then see what the scatter plot looks like. And we're going to see very quickly it's an exponential kind of curve. So we're going to use the calculator to get that exponential equation and then use that to make some predictions based on the data we have. Okay, so the first thing we have here is these are years since 1900 and the percentage of our US population that is over 85 years old. So it was very steady for a while from 1900 all the way through 1930. It was only about 0.2%. Then it started creeping up and then it started creeping up a little bit faster. Right, so if I want to put this in my calculator, remember the first thing we want to do is enter the information in. So we go to stat and then we edit in the information. I've already put the information. List 1 is the year since 1900, so the 0, 10, etc. And then list 2 is my percentages. All right, so I've got that all in there. Then I want to go to y equal. We want to turn our plot on so we can see that scatter plot. Then we'll quit from there. And we go to zoom, and we want to go back to zoom stat. So that'll fix the window to see these statistics here. And I hit enter. And there's my data. And very clearly, it is not going to be a linear model. It could perhaps be a quadratic model, but in this particular problem, we want to look for the exponential. All right, so we're going to quit here, and we're going to go back to stat, and we're going to go to calculate. Now, if I hadn't been told that I am supposed to look for an exponential model, I might go ahead and start with a quadratic because it kind of had a low spot and then goes up, and then compare my r squared. But I'm going to skip that for here and go right to, oops, past it, number 0, exponential regression, EXP reg. All right, so we'll select enter. And if I want to get my calculator to paste the equation into my y equals so I can use it in a few minutes, I'm going to remember to put the arguments in. So second, number 1 to show we start with list 1, comma, second, number 2 to show the second thing draws from list 2, comma, and finally, we're going to tell it where to paste it. So vars, go to y vars, and we're going to choose function y1. All right, so it's going to choose from list 1 and list 2 and paste in y1. Now I execute by hitting enter. It thinks a minute, there we go. And it gives me this information here. And you can see that r squared, excuse me, r squared is almost 96.5%, 97%. So it is a really good model for us. So if I use maybe 4 decimal places to get the most accuracy, if I'm going to copy this down, pay attention to MyMathLab. What does it ask for? 4, 6, whatever number of decimal places, and round appropriately. For this one, I chose to round to 4 decimal places. So you can see, I'm going to move this over, how I just took my A, 0.1377, and yep, I keep it there. Oh, and I actually did that wrong, didn't I? Let me fix that. That should be 7. There we go. And then the B, it says times B that gets raised to the X, so 1.0238, and I did do that one correctly, raised to the X power. All right, so that is my equation. Then the next question is, can we use this model to estimate the percentage of 85 and older in 2021? Okay, well, remember my X stands for, in this equation, it stands for the year since 1900. So 2021 would be 121 years since 1900. So since I have this pasted into my y equals, I could look at my graph. Right, and I can see it's a really, really good fit. It doesn't quite get all of them perfectly, but it's really close. There's a couple ways I can answer the second question. If I want to change my window, it actually is going up to 121, but I'm going to change it to go to maybe 130. All right, just to go a little bit beyond, and I can look at my graph again, and then I can get my answer directly from my graph. All right, so this is one option. I'll show you a second, just a minute. All right, so it's got it graphed. Then I can go hit, second trace to get to my calculate and say I want the value when X is 121. And it's going to say about 2.377. All right, so let me go out of there and say, here's another way I could do it. I could go over to my y bars and say, use y1 as a function and do 121. Oops, the parentheses in there, sorry. Parentheses 121. So we're using y1 like an f of x, right? So f of something means you plug that number into the equation. y1 of 121 means we're going to plug 121 into our equation. And I hit enter. And again, the answer is 2.377. So we'd round that to 2.4. All right, so let's see. So we said about 2.4%. Moving on, let's look at our last question here. This one says, can you predict the year in which the percentage of the population will be 5%? Okay, so now they're not giving me the X to insert and calculate. They're giving me the answer. They're telling me what they want the answer to be. They're telling me what they want the Y value to be. So I have a couple options for this as well. We've already got this graphed in here, right? We've already got it graphed. So if you remember back to the beginning of our unit here, one way that we solved these problems was just graphically. We didn't have to use any algebra. So I'm going to put y is going to be equal to 5. I'm going to go adjust my window and make sure that my y values go up high enough. It doesn't, so let me change that to, I'm going to change it to 6. And I'm also going to go ahead and change this to maybe, I don't know, 200, so that we go all the way up to 2100. And now let's take a look. So there's our original data, and then our model that follows it, and predicting for forward, extrapolating. There, that horizontal line is representing the 5% mark. So if I want to find where this is, how long it takes to get there, I'm going to go ahead and go to second, calculate, and we want to intersect these two. So I hit enter for intersect. First curve, I can see it's blinking right here on my exponential curve, and so I just hit enter. Second question is this your second curve? It's the horizontal line. Yes, hit enter. And now it says, you notice guess. So I want to make sure that I move that blinking cursor close to where the two curves intersect. And it's about there. So I hit enter. It thinks a moment and it says your intersection is when x is about 152.58. So we'd round that up to 153. So that would tell me that about 153 years after 1900, or the year 2053, our percentage of people over 85 is going to be at 5%. Right, so for your notes, I went ahead and put in a couple screenshots there just so you could see how you could adjust that. But remember, the feature that we used was the intersect button. If you have questions, just let me know.